Aloha, my name is Robert, and welcome back to the Net Papakahana Online Professional Development for the Canoe project. Today we'll be talking about Module 7 of 15. Just like before, we're going to start by going to our website, www.stemd2.com. That's www.stemd2.com. After you've logged in, let's go ahead and go to Students, and let's build a canoe. Now we're going to go down to Unit 3, because Module 7 is in Unit 3 of the Go Math book. Here we are in Unit 3. We can read the introduction for Unit 3, or we can even watch the video for it. Whenever you're ready, let's go down to Module 7. Here we have the list of activities for Module 7, which is about solving linear equations. The first activity we'll be talking about today is Canoe 7.1.1. This is the first activity that corresponds with Lesson 7.1 in the Go Math book. In this activity, we'll be learning about a canoe paddler named Keone, who is training for both a short distance race and a long distance race. To train for a short distance race, Keone usually paddles a certain distance really fast, and then he paddles another distance slowly to cool down. Over here it says that Keone trains for a certain race by paddling 3 laps really fast, and then cooling down by paddling 6 more miles. If y is the total distance that Keone paddles in one day, and x is the distance of 1 lap, then we can write an equation for y in terms of x. Once again, if your students feel comfortable with it, we can use LaTeX. So we can type \open parenthesis to let the computer know that we are typing a LaTeX code. And then we'll type y equals 3x plus 6. And then to finish the LaTeX code, we can type in \close parenthesis. So if the students copy and paste this as their answer, then you as a teacher will see this instead of the LaTeX code. This equation happens to be really simple, so it's perfectly fine to type in y equals 3x plus 6. In question 2, we have that the distance of a lap is 1 mile. So from this, we can use the previous equation to figure out how much Keone paddled in that day. In the next question, we see that the length of a lap is 4 miles. So once again, we can use the first equation to figure out how far Keone has paddled in that day. Keone also paddles for long distances. To do this, he paddles 5 laps at a moderate speed, and then he paddles 2 more miles in order to cool down. Once again, we want the equation for y, the total distance paddled, in terms of x, the distance of 1 lap. So we can use LaTeX to type in y equals 5x plus 2. And we can copy and paste this code into the answer. Additionally, we can use this equation to solve a few more questions. Finally, we are faced with a scenario where Keone wants to paddle the same distance, whether he's training for a short distance or a long distance race. In other words, we want to solve the situation where the first equation is equivalent to the second equation. That's it for this activity. Please go ahead and pause the video and read and reflect on it. Alright, welcome back. The next activity that we'll be talking about is Canoe 7.3.1. In this activity, both Keone and his friend Micah are training for a canoe race, but they have very different training styles. Keone likes to keep his training changing, while Micah likes to keep his training consistent. If we go down to the first question, we have a table that describes Keone's training for a month. Because Keone likes to keep his training changing, he will start off the month paddling a short distance, and every week his distance will go longer and longer. So on the first week, he paddles 1 lap and 3 more miles for his cool down. In the second week, he paddles 2 laps and 3 more miles for his cool down. This goes on and on. For the first question, please go ahead and copy this table and fill out the expressions that are missing. With this table filled out, we can write an equation for y, the distance traveled in a month, in terms of x, the length of one lap. Micah, on the other hand, likes to keep his training consistent. So every week, Micah paddles 2 laps and cools down for 6 more miles. With that expression, we can then write an equation that describes how far Micah has traveled in 1 month. If, at the end of each month, Keone and Micah paddle the same total distance, how long is the length of 1 lap? To solve this, we will need to use the equation that we came up with that describes the distances that Keone and Micah has paddled within 1 month. Finally, we finish this activity with an open-ended problem. Here we need to come up with our own training plan to get better at a sport. If you are comfortable with it, please allow your students to go online and get some expert advice. Please allow them to use what they find online to figure out their own workout schedule. That's it for this activity. Please go ahead and pause the video and review and reflect on it. Let us know how you can use this activity in your classroom. Welcome back. The next activity that we'll be looking at is Canoe 7.C.1. This is the first cumulative activity of Module 7. In this activity, we will be talking about building on a heavy outrigger canoe. The more we build on it, the bigger it gets, so it gets heavier. As it gets bigger, it can also increase its buoyancy. In this activity, we have 2 building companies that want to increase the size of this canoe. The way that they go about in increasing the canoe size is described by this story and the following one. You must model these stories mathematically and decide whether or not their plans are feasible. In other words, are the companies able to make the canoe bigger and therefore carry more weight, or will they only make it heavier until it sinks? So this is one of the first activities that we have where we introduce the concept of buoyancy. We will revisit the concept of buoyancy several times more throughout the canoe project. Finally, we end this activity with an open-ended question. In this activity, we want the students to think about the things around them and whether they sink or float in the water. And we want them to think about what determines whether something sinks or floats. That's it for this activity. Please go ahead and pause the video and review and reflect on it. Aloha, that's it for Module 7. We'll see you again for Module 8.